Welcome to Data Analytics Tools Series. I am Dr. Danielle Morin from Concordia University in Montreal, Canada. The topic of the lesson today is partitioning. Partitioning is often necessary to avoid model overfitting. Overfitting occurs when the analyst builds a model that does a great job of explaining the sample of data on which it is based, but fails to accurately predict outside the sample data. Because we have abundance of data, we have the possibility of avoiding overfitting by decomposing the dataset into three partitions: the training set, the validation set, and the test set. Each set has its own goal. The training set consists of the data used to build the candidate models. The validation set consists in the set used to evaluate which candidate models is the most accurate at predicting when applied to data that were not used to build the model. And finally, the test set. It's the data set to which the final model should be applied to estimate this model's effectiveness when applied to data that have not been used to build or to select the best model. Excel Frontline Solver Data Mining offers two types of partitioning. The first one, most used, is the standard partitioning, and the other one is the oversampling approach, which is the case when we are dealing with rare events. Let us go to Excel and illustrate those two approaches. As a first example, we will consider this dataset that contains 43,193 observations. We will attempt to classify that into three sets. I will go from data mining to partition, and I use standard partition. All the variables will be included in the selected variable section. The next, I need to make sure that the first row contains header. This is clicked. Therefore, I have a few options. Either I use a partition variable, so that means there is an additional column in my data specifying where these observations will go, but most likely we have to pick up row randomly, and we would use the set seed 1, 2, 3, 4, 5, which is the same approach we have used in cluster analysis. The next portion here is to say what percentage of data do I want in each of the sets. We will, if we like, let Excel decide, or demand equal percentage, or specify the percentage ourselves. This example, suppose I would like to have 20% for my training set. I would like 50% in my validation set, and finally, I would like a 30% in my test set. And then simply click here, and Excel will give me the following printout. It recognizes that I have in the system 43,193 data points, and it understands I want 20%, 50%, and 30%. And it will give me here the number of observations in each set. The training set, I have 8,639, the validation 21,597, and the test set 12,957. It is giving me also the partition data. It means that the first 8,637 rows of data correspond to the training, the next 21,597 to validation, and the next 12,957 to testing. The partitioning that I have done will be carried over when I want to do another analysis. Let's look at the other example of oversampling. I will use oversampling when I have a rare event. Suppose in this situation, I would like to predict loan default or not. Basically, I want to classify those customers as loan default or not. This is the column here. So I would like to know how many observations, how many people have default their loan. So if I just take the sum, I have here a total of 782 clients. But what is this percentage? So I will take this percentage over the total number of observations that I have, 43,193. And it will give me 1.8%. This is so small that it is considered a rare event. We will often think about rare event as less than 10%. Let us use this, but let us now partition this data set. I will go to partition, but partition with oversampling. The first step is to bring all those variables to the other side, to all of them. I send them variables in the partition data. So when all the variables are on that side, I need to see which one will be the output variable, and the output variable will be my loan default. As we can see here, I have to transfer all the variables, and only later I will put my output. Will I take a seed? Yes, again, 1, 2, 3, 4, 5. How many classes? We have only 2 classes, either default or not default. And the percentage of success in the dataset is 1.81%, as we have just calculated. In order to understand better the training of the model, I will force a 50% of the success in the training set. And then I will specify how much of the leftover, the percentage of validation data that will be taken away as the test set, and I will put, I can choose 30%. But the most important part is I will specify, I will oversample the training set. I will put 50% success and 50% not success. Therefore, it will be easier to find the characteristic of those who default. And the printout will give me the following. It understands that I want 50% in the training set, and the 30% of the validation is taken as the test data. Therefore, I have in my training set 782, 15,078 for validation, and 6517 for testing. You will note that the sum of those 3 sets is not anymore the 43,000 that we had originally, because we have forced 50% success in the training, and in order to keep the same ratio of 1.8% in the validation and testing, we could not use all the observations. That's why the total is different. And now, again, we can follow my first 782 rows will be my training. The next group will be the validation, and the next is the testing. Now we see that these 2 examples illustrate that we have standard partitioning and oversampling that will help us analyze our big data set. I hope you enjoyed this. Thank you.